in theory. Okay. Whatever are we going to do on Friday evenings during the hiatus? Yeah, get drunk. Lots of options. People are saying in the chat.
Garden. Oh my goodness, the
Yeah,
weeds
garden.
are taking over.
Yeah, exactly. I've really got a weed.
I I live in a part of the country where I don't think it will be dry again until August. And
Dry. You think? Oh, you think it's gonna rain and rain?
it's well, we just like have high humidity and so everything my squash plant is growing roughly a foot a day.
Yeah, that's
And
amazing.
I'm trying to wind it up a trellis and just like it's going an entire rung of the trellis
Yeah,
every day. And
yeah.
I can't keep ahead of the weeds.
I mentioned this before. Doesn't it feel a bit like like you're attempting to cage a tiger? And you're just like,
Yes.
if you can just make it through this year without that squash plant destroying your house. I just imagine it's gonna be your squash plant just tearing your roof off your house and throwing
Oh,
squashes everywhere. You know?
we have grapevines that do that.
Yeah,
They
yeah,
they reach in through the trellis towards the house and they consumed a mountain bike one year.
yeah,
They
yeah, yeah. It's funny. Oh my god, I had a every year, like we have an irrigation system that we set up on our property. It's all these like silker
yeah.
hoses and this big long octopus machine that we've built. And so we turn it on, and so I turned it on for the first time in the season, and I could hear psh, and everything seemed like it was watering. So I walked away, and then I noticed about an hour later that there was like a fountain of water just coming out of the middle of my yard. I'm
Uh-huh.
like, how is this even what?
Yeah.
And so I went over there and I pulled up the hose. And so yeah, one of my garden hoses, the one we use for just hand watering, had just gotten completely covered over by the grass to the point that it had just become one with the yard. And I had lost it, right? until I had this little mini fountain in the middle of my yard. And yeah, and so same thing, like you just living in the coastal rainforest, we have the same situation where just anything that you're not out there hacking away with a machete just becomes one with nature again.
I swear there's an entire ecosystem in our grapevines. One year we went to go out the back door and there was an opossum in there, right at eye height, just happily munching down on the grapes. And my husband was like, "No, we do not need dinner that badly," and just aborted and went
Yeah,
back
yeah.
into the house.
Those are your grapes now, possum.
Yes.
Enjoy. Yeah. I tell you, we've got raccoons that come up onto our back deck.
Yeah.
Yeah, and so it's so cute to sort of see them. The one, he'll sit there and just watch us and then just move his paws around while he's feeling for the seeds, but he's keeping an eye directly on us. Or our dog, which is on the other side of the glass,
Right, right.
really intently watching the raccoon. The raccoon's maybe a meter away from the oh, hold on a second. I gotta give my phone to my wife. 1 second. I'll be back.
Okay.
Oh.
Hello, everyone. Welcome to Pamela and Fraser talk randomness as we give time to settle in for the show. Today, we will eventually get to talking about observing the moon, but apparently, we're going to talk about our gardens first because plague times, we all have gardens.
Sorry about that. Normally, I try to be the consummate professional, but it was an important phone call that was coming in. Okay. So sorry, what was that?
Oh, we were just talking
Oh, yeah.
gardens. Do you still have raised beds?
Yeah. Well, I have one raised bed. I turned everything else into flower beds, but we have
Okay.
one raised bed filled with strawberries, and in fact, it is the time. I don't know if I mention this again every year. I always, I'm like, man, do I really want to have this whole bed filled with strawberries? And then in middle of June, I'm just feasting on just the best strawberries. I'm like, yes, I always do. I never don't want strawberries.
Yeah, it turns out year one of planting strawberries, it doesn't look like I'm going to get any strawberries.
Yeah.
But next year, I'm going to have all the strawberries, all of them.
I'm going to say hi to some people. Hello to A&T, Andy Cowley, Astro YYZ, Ben Kalo, Bruce Bushy, Coalfire, Corey S., Daniel McCool, Dustin Haskins, Dustin King, Esther Gagne, Frank Tippin, Gord Dewis, Graham W., Guido Bibra, Ian Farquhar, John Seffield, Johnny J., Kylie Cerna, Larry Beckham, Magnus Timer Jensen, Mark Sheeran, Michael Holland, Nancy Graziano, Paul Disney, Paul Gracie, Pedro Mira, Rich Wilson, Rich 901, Theron, Thomas Traniker, Topes, Trey Harmon, Wayne Johnson, and Zapvan Zapvan. Hey, everybody. Oh, I got to get the link up for next season. I'll get the Twitch people too.
So I've got them. So hello, Adam Altogether. Hello, another TW viewer. Hello, Aiton, Balf, Broken Symmetry, Defective Automation. I like your name. Denu, Electrical Longboard, Genry, Hodor 0817, Huldars, Ironheart, Limp Rimple, Larux, Null Denominator, Tom Van Scooter, Tropical Tom, Wayne Johnson, and Zine.
Hey everyone, welcome to this penultimate episode of Astronomy Cast. Of course, not penultimate forever, but just penultimate for this season. Was it season 11, season 12? Are we ending season 11 or season 12? I forget.
No. We're a teenager now.
Yeah.
So we launched in 2006. So this would have been our 13th season.
Okay, great. We finished season 13. Someone can count and tell us in the chat what season this was.
Was it 13 or 14?
No, what?
Hold on. So there was the season that ended 2007, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. 13th season.
So this is ending
20. So this is our 14th season.
We're ending our 14th season of Astronomy Cast. Okay. Then we're going to be pushing into our 15th season. We'll be entering our 15th season of Astronomy Cast next year in the fall, in September. Yes. And of course, we use this time to just recover from 10 months of intense streaming, content creation, and having to worry all the time about whether or not we're going to be able to find our way to high-speed internet and a fast computer. And it allows us to do things like
rebuild the website.
Right. Yeah. I mean, of course, it make it sound like we're just going to go and sit on some beach somewhere. And the reality is, of course, we're just going to work on a whole bunch of projects that require more deep thought and uninterrupted time. So
it's true.
Yeah. But I think it's good for you too. Get outside, enjoy, listen to the backlog, whatever it takes. And of course, you'll still be creating various projects. I'll still be creating a lot of projects, so you'll still see us. But this week, we're going to talk about the moon. Next week, we're going to give you our guide to what to see in the summer, which is a thing that I think we've done this before. So this is almost turning into a regular event. So, Thomas Drake asks, how much is season 1 now in need of an update? Probably not much. We keep asking ourselves this question, and we go back and look at some of the older topics. Yeah. We just did a big refresh on all the new stuff that we have learned, and it turns out there's like a lot of little stuff, but not a lot of big stuff. So, okay. Although with the whole crisis in cosmology, it's getting super interesting. So that may be a totally next couple of years that we get to throw out all kinds of ideas, which will be fun.
It's true.
Okay. So,
I'm
ready to press record. If you're ready to press record.
Yep. Okay. Pressing record. Recording.
I am also recording. Here we go. Astronomy Cast, episode 575, Observing the Moon. Welcome to Astronomy Cast, our weekly facts-based journey through the cosmos, where we help you understand not only what we know, but how we know what we know. I'm Fraser Cain, publisher of Universe Today. With me, as always, is Dr. Pamela Gay, a senior scientist for the Planetary Science Institute and the director of CosmoQuest. Hey, Pamela, how you doing?
I'm doing well. How are you doing this fine night before summer solstice?
I know. It's... I've got to say, we've been doing the virtual star parties, and they've been having to go later and later and later, and so now we have to start at 9 o'clock. It's going to be nice that nighttime comes earlier now, and we'll talk a bit about this next week. About the things you'll be able to see in the nice warm summer nighttime sky in the northern hemisphere. But as you probably know, this is going to be our penultimate episode for season. We're doing the math beforehand. What do we say? Season 14.
We think it's season 14.
We think we're on season 14 of Astronomy Cast. So we start up again in September. Typically, we used to start with whatever interview Pamela would do at DragonCon, but I don't think that's going to be happening this year.
No, not so much.
Yeah.
Not so much.
So we will, but yeah, we will be picking up again in 2 months. So this episode, next week's episode, and then we start back up. But one thing I just want to promote, if you haven't already, is you should sign up to my weekly email newsletter that I write every week. In fact, I'm in the midst of writing it right now. I send it out on Friday mornings, and it is got 12 to 20 stories in it, links to dozens of other interesting stories, great pictures, astrophotography. It is a one-stop shop for every piece of space news that's happened this week that I find interesting. So you should go to universetoday.com/newsletter to sign up. It's totally free. There's no ads. It's just Fraser's random musings on what's happening in space and astronomy.
It's awesome. You want it. And when he calls it a newsletter, he's lying. It's more like a magazine.
Yeah, it's a magazine.
It's a lot, people.
It's a novella. Yeah. Yeah. Each one is about, I'd probably say it's about 15,000 words that I write once a week. Yeah. Is that right? No, not that many words. 5,000 words. Probably 5,000 words. All right. As amateur astronomers, we curse the moon every month. Seriously, why doesn't someone get rid of that thing? This week, something occurred to us. What if we actually pointed our telescopes at the moon? What would we see? I hate the moon. Because half of the month, for goodly portions, you look up at the moon and you look up at the sky and all you see is the sky glowing because of the stupid moon. But
you just need to pick your times better.
Yeah, exactly. Only look at space for 2 weeks when the moon is below the horizon, the times when it's not raining here on the West Coast, which, face it, that's all the time. Pick your times better. Fine. So let's look at the moon.
So the moon has this habit of orbiting the planet, which is better than like colliding into the planet or something. And this means that, yes, it is up half the month, but the time of day that it's up changes constantly. We are recording this on June 19th. Tomorrow, midnight here in the Americas, Sunday morning in Central Africa, the Middle East, and Southeast Asia, there is going to be a solar eclipse.
Yeah.
And that means the moon is new and not visible at all.
Right. So the irony of this episode is that we're talking about observing the moon at a time when the moon can't be seen.
But it also gives us a glorious chance to remind everyone of how it is that folks like me remember when the moon is going to rise and set. So when there's a solar eclipse, the moon is generally going to be rising the exact same time as the sun, roughly 6 a.m., setting the same time as the sun, roughly 6 p.m., ignoring the fact our planet is tilted and things like that.
Yeah. But new moon is a good time for a fresh start, right? That's a good time to start observing the moon as you move through the cycles of the moon. And it's pretty amazing how many interesting things there are to see and how it looks different as it moves through all of its phases.
Now, as the moon starts migrating towards full, it's going to be rising 45 minutes early. Sorry, I'm going to get this wrong. As it migrates towards full, it's going to be rising 45 minutes later every day. This means that what is 6 a.m. tomorrow will be 6:45 the next day, will be 7:30 the next. And as it rises a little bit later and a little bit later, it's expanding its angle away from the sun on the sky, until eventually you get to the point that the sun and the moon form a right angle. And what we see in the sky is a first quarter moon. The first quarter moon is rising at noon, quarter turn of the Earth away from sunrise, and we only see half of the face of the moon illuminated. And it's called a first quarter because the moon is a three-dimensional object.
Right. So even though it looks like you're seeing only half the moon, you're actually only seeing a quarter of the moon illuminated from your perspective.
I have gotten that wrong on an exam when I was a student, and I will never forget it.
Right. But the quarter is a very dramatic time to see the moon. But I mean, I know there's a lot of amateur astronomers who will start chasing the moon moments after the moon has passed at its closest time to the sun. It depends on how far it is above and below. In this case, it's passing right in between the sun and the Earth. But there are times when within a day you can start to see the tiny thin little crescent of the moon, and even start making your observations of the moon then.
And this is important in many different Muslim cultures where they're still using the first sighting of a moon afternoon to mark the starts of their various months and their various holidays. So if you're waiting for a holiday that involves fasting during daylight to end, you're very interested in that lunar phase.
Right. And it is pretty amazing. And I think, I mean, depending on how good of a view you have to the east, sets in the west. So how good of a view you have in the west, you get that first night when you see that really thin crescent moon after the sun has gone down. And it was there all along. It's only when the sun has gone down it is actually visible and easy to see. And it's one of the most beautiful times to look at the moon in a small telescope, because you're getting these extreme shadows on the surface of the moon showing you just a tiny little hint of what's to come.
And one of the awesome things that we encourage all of you to do is to take advantage of the fact that you're listening to this, hopefully when most of you are just barely starting to be able to see that crescent moon at sunset. Now, what we encourage you to do is to go out at sunset every night that's clear and not raining, and see if you can find the moon and spot the fact that it's in a different place.
Yes, at the same time,
and its phase is radically changing. A lot of people will just somehow be oblivious to the fact that the moon is actually up during daylight. That first quarter rising at noon, it means it's like around all afternoon with you.
Yeah. I find I get sort of refreshed, reminded of the moon this once a month, because you get that first night where you get that thin little crescent moon, and then the next night the moon is a thicker crescent and it's a little bit higher in the sky than it was the night before. And each night it goes, you see that until it moves to that quarter moon that you were mentioning. And it's often that will take, you'll have about 5-ish nights, I find, where it moves up to that quarter moon, that you're more aware of it every night, especially if it's like 5 clear nights in a row where the night is, you don't have clouds and stuff. So you kind of just go at the same time, and there it is. And especially when you've got something bright like Venus or Jupiter in the sky in roughly the same location as well, because now you've got a vantage point to go, oh, it's much farther from Venus than it was the night before.
And one of the awesome things that you can do as you're watching through the month the behaviors of the moon is you'll eventually be able to see that full moon rising on the horizon. And the summertime is the perfect time to learn how to photograph the moon on the horizon, because with the daylight sky still visible, you have a pale moon against a still blue sky. And that is so much easier to get right photographically than a full winter moon against a dark black sky. Right, the contrast on that's almost impossible.
Now you're jumping around the timeline here. So as we, and we'll get to the full moon, but for now, what kinds of things, either just with your eyes or with a telescope, are you going to be wanting to see in in the phases leading up to that first quarter? What are the advantages of observing at that point?
So, one of the most amazing things to do when you still have that slender, slender crescent is you can see the daylight side of the moon as that brightness, but you can also see the nighttime part of the moon illuminated by earthshine.
Right.
And the fact that you can see both parts simultaneously is something we don't usually think about. But the second you try to take a photo of it, it becomes unavoidable. It's just there, throwing off your camera's ability to figure out how long it should keep the shutter open. Our Earth is enough light scattered off of it to change how we see the moon.
Yeah. And I know that astronomers are actually thinking of using similar systems, that if you could see the earth shine reflected, or the planet shine reflected on the moon, you would actually be able to learn a lot about the planet itself. You can actually see where there are oceans, where there are weather patterns, continents, etc., just by the way the light is reflecting off the planet onto the moon. So if you were able to observe moons around other stars, around other planets, around other stars, you could actually learn a tremendous amount about the planet itself because of that shine. The thing that I think a lot of people don't realize is that the shadows on the moon are constantly changing. And so as we get to that quarter moon, that's when you see large portions where essentially the craters are in some of the best relief, as opposed to, say, looking during a full moon.
And there's terminology that makes this conversation easier. The brightly illuminated part of the moon, that's the daytime. The dark part is the nighttime. And that line that separates the day from the night is called the terminator. And as you get closer and closer to the terminator, the shadows get longer and longer and longer. So when we're looking at the crescent moon, we're seeing pretty much just shadows and light. That's it. As the terminator comes closer towards the center, we're starting to see the sun hitting directly on the edge of the moon. So the shadows get shorter as we get closer to the edge of the moon, and the longest shadows are on this long stripe that we're looking straight down on in the center part of the moon.
And think about that, like you're here on Earth during, like, just before sunset, and the sun is low in the sky and the shadows are really long. You see these big long shadows. And of course, when you're a photographer and you want to take pictures of beautiful mountains, it's called the golden hour. That's when you take pictures, because you get these really long shadows that will show all of the features in this really highlighted way. And it's the same thing when you're looking at the moon through a telescope, through binoculars. On the one side that is in full illumination, everything is completely sort of hit face on, and you don't get that structure. But then right along the terminator, you do get much longer shadows. And what's amazing is that over the course of this month, as the terminator moves, different parts of the moon are illuminated at different points.
And the areas of the moon that we're seeing where the sun is primarily going straight down, that allows us to see the natural color contrasts between the bright white regolith and the darker gray mare of the moon, the two different mineral compositions that we see on the surface. But the places that have those long, sprawling shadows, that really allows us to see where are the craters and where are the hills, mountains, and volcanoes.
Yeah.
The moon is geologically diverse in its shapes, and to see that we really need to see the shadows.
And so if you're wanting to do astrophotography of the moon and you want to take the best possible picture of any crater or any feature on the moon, you have to figure out when the terminator is going to be as close as possible to that feature. And that changes day by day, even hour by hour, depending on how sort of high resolution, how close, how much magnification you're trying to bring into your image. So it's actually a lot. Like, as an astronomer, you will want to take pictures of different regions of the moon on different days. And you actually want to plan this out. Today I'm going to go after Copernicus. Today I'm going to go after the Apollo landing site. Today, and you just know. And there's a lot of interesting features that are revealed, like there's the lunar X, and you can only see it on a couple of days when the shadows are just right. Feels like Indiana Jones kind of.
And the short summer nights aren't best for this, but during the winter, you can actually go out and start your night with a nice quarter moon rising, take a look along the Terminator, go observe a bunch of other objects, come back and see the moon's shadow slowly change over time as more and more things come out of shadow and come into the light.
So now we shift into that next portion where we go from the quarter moon to the full moon. What's that called?
That's the gibbous moon.
Less interesting, although I find visually it starts to look just like a full moon to me, but the Terminator is continuing to move across the moon and illuminate other chunks of the moon that you can see.
And for whatever reason, a lot of people just find the gibbous moon less satisfying. I can't really explain it. It's just like crescent is awesome. First quarter, meh. Gibbous, who cares?
Yeah, who cares? Yeah.
But that full moon,
yeah.
it leads to all sorts of I want to say myths, optical illusions, and just awesome photography.
Yeah, so you're talking before about being able to take a really amazing picture of the moon as it's rising down by the horizon. And of course, I think we've all experienced that moon horizon illusion, that it looks like, look how big the moon is just as it rises. What's going on there?
It's just psychology. Our up in the sky lacks anything to tell us how big or how small it is. And so in the vastness of space, our brain is like, moon is small.
Look at that little moon. Yeah.
That little tiny moon. But when the moon is low on the horizon, our brain is able to say, it's bigger than that tree over there. And our brain is right. On the sky, it does appear bigger than that tree, but that doesn't mean it's actually bigger than it is straight overhead. And you can learn this or prove this by going out when the full moon is rising and stick your thumbnail, stick your pinky, figure out what fits
Yeah, it
best.
works with the pinky.
Yeah. Over the surface of the moon, and then wait for it to get higher in the sky, and you'll find it's still the same finger that covers the moon.
Yeah. And if you want an even more accurate thing, take like a small, like an aspirin size pill, right? And then hold that out at arm's length. And you should, same thing, the pill should just perfectly cover the moon. And then try that when the moon is down at the horizon, and try that again when the moon is really high. And you've seen some amazing pictures where people take a picture of the moon every couple of minutes. And so you get these little circles that move up, and the moon stays precisely the same size the whole way up. It is not changing in size. It is all in your mind. And yet
it's entirely in your
I'm
mind.
fooled by it every time. Like I never can just rationally go, oh, yeah, the moon is small, just like it always is. It looks huge.
It really does.
Yeah.
And there are photos out there that make this illusion even greater by using massive telephoto lenses.
Yes.
So if you can get a good distance from a building, a park, a cliff, something you know the moon is going to rise behind, and zoom in on it, you can catch a building, because it's so far away, appearing smaller than the moon on the horizon, and get these amazing shots of essentially the moon dwarfing historical places, barns.
Yeah.
There's some amazing videos out on the internet. One of my favorite shows people at a park just basically going about their business as silhouettes in front of the moon.
And there are some great apps you can use to calculate where the moon is going to be for this, and for you to calculate where you should go to be able to capture this image. But you can also do this, go out to a park sometime, or if you want to try and capture one of these images, like the night before the full moon.
Yes.
Run through, wait for the moon to rise. It's going to rise a little earlier than the next night. and then you can set everything up and make sure you've got it, and then the next night do that. Another great experiment that you can do if you want to observe the moon, because the full moon is kind of boring to take a picture of. You get interesting coloration on the surface, but you don't get those craters because there's no Terminators, so there's no shadows. It's just straight on moon. But you can take pictures, like take a picture 1 month where you absolutely lock down how far you're zooming, the direction your camera is pointing, exactly everything the same. And then a month later, take another picture, hopefully you get clear skies, of the moon. And then a month later, do another one. And then when you compare these different images and stack them on top of each other, the moon will be different sizes.
And the other thing you have to watch out for when doing that, though, is the moon does wobble a bit. It doesn't actually wobble. Its orbit changes enough month to month that exactly where on the horizon it's rising and setting is going to vary.
Yes.
I have made the mistake of lining my camera up on the wrong silo in the distance. So don't be me. Learn from my mistakes.
Right. And it goes back to that idea that we get these lunar eclipses and solar eclipses because it takes a few months, and sometimes the moon is above the plane of the ecliptic, and other times, or the in between the Earth and the Sun, and then other times the moon is below, in between the Earth and the Sun, and then every now and then the moon is directly in between the Earth and the Sun. And so where that moon is going to appear on your horizon depends on which way we are. And you could practice starting to predict when you're going to see these eclipses, because you can see the moon moving closer and closer each night, each month, from the point that it's rising until it lines up. Of course, you also have to balance that with the tilt of the Earth and as the seasons themselves change, etc. But you can get a sense of when the moon and the Earth and the Sun are all going to line up, and we're going to get that lunar eclipse, solar eclipse somewhere on Earth.
And lunar eclipses and solar eclipses generally come in groups. We have a solar eclipse tomorrow for some parts of the planet. Unfortunately, this is a really cruddy alignment. So it's not a total solar eclipse. It's what's called an annular eclipse, where the moon is sufficiently far away from the Earth that it appears smaller than the sun on the sky. And it's also about as bad an alignment as you can get and still get an eclipse, because instead of getting that perfect, what's called an umbral lunar eclipse, when the moon passes through the darkest part of the Earth's shadow, we had earlier this month, and we'll have 4th of July weekend, what's called a penumbral eclipse, which is when the moon just gets slightly dimmer because it goes through the outer part of the Earth's shadow, and it's not very exciting.
Yeah, very boring.
Yeah.
So as the moon continues to shift through its phases, what's the next phase?
Well, third quarter, when we're seeing the illuminated part of the moon has shifted around again.
And what do you call a moon that is starting to shift from full moon to new moon?
I always get made fun of this.
I know.
Because I learned how to say this before.
By reading it.
Yeah.
It's a waning moon. Here, let me prompt you. It's a waning moon.
So for those of you who haven't heard, I made the mistake a while back of saying Waning, because that's what I read when I was a small child.
Yeah.
And no, I was wrong. So now I just avoid the word, avoid it completely.
The moon waxes and wanes. I love it.
And here is when you can get back to observing in the early evening. So with the full moon, we had the moon rising at, again, ignoring planetary tilt and seasons, the moon rising at roughly 6 p.m., setting at roughly 6 a.m., being straight overhead at midnight. That's the glorious thing about the full moon, is it's with you the entire night. It's also the annoying thing about the full moon.
Like a moon could show up and then it should just get lost and let us look at everything else in the night sky. But no, it's there for the whole night. So the only thing that's nice about the waning moon is that it shows up 45 minutes later every day. And so you can start observing and the moon isn't up, and then you can observe for a little longer and the moon isn't up, and then eventually, finally, the moon shows up to ruin your party.
And so when you get to that third quarter moon, it's rising at midnight. So first quarter is noon, third quarter is midnight, and that's the phase of the moon that you have happily at sunrise and joining you until noon the next day. Now, this starts to get at how we can tell if we're looking at a waxing or a waning crescent. Do you know this trick of the horns?
The horns, no, the horns point towards what?
So, when you have a crescent moon on the horizon and there's no sun, you'll see the fat illuminated part of the moon pointed roughly towards the ground, the two horns of the crescent facing up, and the illuminated part always faces towards where the sun is.
Right.
So, if the sun isn't visible, that means that the sun has already set, and that illuminated part that you're seeing, that is pointing towards the sun. Sun is below the
Right.
horizon and the horns are up.
Yeah.
And yeah, it's cool.
Yeah, I mean,
Horns up.
I mean, even with the quarter moons, but especially with that crescent moon, you see it absolutely, right? The sun goes down and then the crescent moon is visible in the sky. And so you can really, it's perfectly pointed towards where the sun is. But I even think about that even more when you see a crescent moon, or even when you see a full moon. You see a full moon and you just know the sun is behind you, right? That's where the sun is. And so you can, if you imagine the universe as this three-dimensional interaction between the earth, the sun, and the moon, and you think of the moon not as this flat disk in the sky, but as this ball, and the way it's being illuminated points the way towards where the sun is. You have just this moment where you realize just the geometry of everything involved. And from that point on, you can always find the sun, even though you can't see the sun, just by looking at the moon. It's such a neat idea.
And the crescent will always be near the sun in the sky.
Yep.
And so it's just how you tell. It's just cool.
And then
I
over the
just
course,
like it.
and then over the course of the month, the night, as you say, the quarter moon, third quarter moon is midnight-ish, and then it just keeps going through until and that is, I mean, that's often a time when you'll see the moon during the day. I find is because you're seeing either being like a third quarter moon, and so it is rising at, say, midnight, or even like 2 in the morning, 3 in the morning, and then you get up and it's 10 in the morning, 11 in the morning, and there's the moon still pointing the way to the sun.
It's true.
Yeah.
And exactly, I think when people see it just depends on where their sky is clear. So for me, it's because I spend a lot of time staring at my dogs in the yard, I'm much more likely to catch evening objects.
Right.
So I see that late afternoon, first quarter during daylight.
Yeah. And you absolutely can see the moon during the day, no problem. And you can even look at it with a telescope or a pair of binoculars. It's pretty great. I mean, obviously be careful with the sun, but you can see features on the surface of the moon during the day, no problem. It's that bright.
And learning how to photograph the moon, I strongly recommend start by photographing it while it's up against that bright blue sky.
Yeah.
And then get darker and darker twilight as the seasons progress. Learn it now and then have it mastered next winter so that you can finally figure out how to get the contrast just right against the nighttime sky.
So it turns out the moon is okay. It's fine. There's some stuff you can do with the moon. It's both interesting to look at during the day and at night, both in a telescope, binoculars, with your own eye, and it is fascinating to learn to take pictures of it, both with a regular wide field view, but also with brighter telephoto lenses. All right, so we won't get rid of the moon just yet.
We need it for other things as
Right,
well.
of
It's
course.
good to have a moon around.
Perfect. All right, well, thanks, Pamela. Do you have some names for us this week?
I do. As always, we are brought to you by you. This show wouldn't exist without your support at patreon.com patreon.com/astronomycast. And I would like to thank Jordan Young, Biri Galwin, Burko Roland, Ramji Anamathu, Andrew Palestra, David Trogue, Brian Cagle, The Giant Nothing, Dan Littman, Stephen Shewater, Laura Kettleson, Robert Plasma, Paul Jarman, Joss Cunningham, Les Howard, Emily Patterson, Adam Annis Brown, William Jones, Infinitesimal Ripple in Space-Time, Ed Loves Science, Gordon Dewey, Bill Hamilton, Sinai, Frank Trippin, Richard Riviera, Joshua Pearson, and Jack Mudge. Thank you all so much for all that you do that allows us to do all that we do.
Thanks, Pamela, and we'll see you next week. Save.
Yes.
This is 575.
Our air conditioner kicked on and the dog decided she's scared of the air conditioner.
I saw your dog there.
I love some people's usernames.
You especially love The Giant Nothing.
I do. I do.
It's like your favorite one to really chew up the scenery when you get to that name.
Okay. I loved The Never-Ending Story when I was a little kid.
Oh, is that we've had this conversation before, I think. That's where it comes from. Okay, I'm done. We're safe. Okay, so everybody, now is your chance to ask us questions about space and or astronomy. Zapfan asks, so how confused were you by the lunar phases when visiting Australia?
Ow, dog. The moons aren't any different when you're in Australia. It's just the moon in general looks upside down.
Yeah. So the phases are the same. It's just in the wrong direction.
And you look north instead of looking south in the sky to find it.
Yeah.
So it was once I found it, it was fine. It just took me a moment to realize, nope, rotate 180 and it looks upside down.
Yes. Yeah. So it is a little weird. It is a little, I mean, it's interesting when I was like here in the northern hemisphere, it really is very much that the moon is pointing down. But when you go to the equator, it's very much the moon is pointing sideways. And I found that weirder than when you're in the southern hemisphere and it looks like the moon is pointing in the other direction up. But yeah, so it was the equator was the one that was the hardest for me to wrap my mind around, but again, it's like we feel
equator at equinox versus north at winter solstice are the greatest extremes.
Yeah. And so we're just so used to this perspective, and it's purely because of where you're positioned on this sphere. Are you closer to the North Pole? Are you closer to the South Pole? Are you closer to the equator? Gravity feels the same because you're all being pulled towards the middle, but it's when you are in one of these other perspectives. Unc Willie, can that be done with a flat Earth?
No.
So much goes wrong when you assume the Earth is flat.
It's true.
Esther Gagne asks, looking at the moon at sunset, I feel that the illuminated portion doesn't always line up correctly with the sun's position. Does this optical phenomenon have a name? So do you know what she's talking about?
So one of the things that always mucks with us is the positions of objects on the sky get refracted by the atmosphere. And so the exact pointing can get screwed up by the refraction by just enough to mess with your brain.
But I think the other part, though, is just that when you see the moon and you're seeing part of it being illuminated, you imagine that's like an arrow that's around the outside of the moon that's pointing you towards where the sun is. But that's not what it is, right? It is that the sun is totally on the other side of the moon, and you're just seeing a little bit of the sunlight leaking out on one side of it. And so you can't use it exactly as a guide.
Yeah.
So
it's a combination of different things that include brains and light all messing with us simultaneously.
yeah. Just remember that the sun is so much farther away from us
Yeah.
than the moon that you're seeing just a glimpse of the direction of it. So it's roughly the portion of the sky that the sun is in, but not a perfect direct link over to it. Nicholas B asks, can you suggest a relatively inexpensive 1.25-inch telescope camera for photographing nebulae?
Okay, so the 1.25 refers to the eyepiece holder.
Yeah,
Um, so you can get that size eyepiece holder
they're cheap.
on anything.
Yeah, $10.
Um, so you want to know a telescope to attach your camera to. I would
No, the camera. So what is the camera to use?
Oh,
Yeah, what would you recommend as a camera?
I would get a Canon. They have their TI series.
Mm-hmm.
So like I have a Canon T7i. I think they're up to 8 or 9 by now. It's the lowest end that you can do astrophotography with.
Yeah,
You can spend more and get bigger chips, better cameras. That is the cheapest you can purchase and still get good photography. It's the series. I'm now on my third version in this series.
yeah. I mean, there's sort of two ways to go about this, right? One is that you go with a traditional, with a like a just a digital camera, like a DSLR, right?
Yeah,
And so you're talking about the Canon, an older T3. You can even go with one of the oldest, like an
yeah,
EOS. Like
that's
you can
true.
go, you can spend $100 and just get like a really old first generation digital camera. But the newer ones you're looking somewhere in the 400 to $1,000 range for a more modern DSLR camera. And what I like about that, as you said, you can adapt. You get you pay $20 for the little mount, and it now you have no lens on the front of your camera. Now your camera
Yeah,
is using your telescope as your lens,
yeah.
and it's pretty good. Or you can go with a dedicated
CCD
CCD
camera,
camera, and that's going to give you a much better quality image. And if you go with a
but you can
monochrome,
only use it on your telescope.
that's exactly it. And so they are a monochrome CCD camera. You're looking at a few $100s.
And while film still exists, don't go there because
Yeah.
film is just not sensitive enough. It's that lack of perfect sensitivity that makes film so much better for
Yeah.
capturing landscapes and human beings and things like that. The perfect linear sensitivity of a digital detector, it will make you a much happier individual when it comes to doing astrophotography.
So I think it's all depending on, like, if you want the best to take the best possible images with your telescope, then you're going to want a dedicated monochrome camera, and you're going to have filters that will allow you to take one image in red, one image in green, one image in blue, and then stack them up on your computer and take your time. If you want a camera that you can use for other things like landscape photography and long exposure and wide field Milky Way and things like
Lightning.
that, lightning, pictures of your friends and family, parties, you name it, then go with a DSLR.
Yeah.
And you will know when you have outgrown the DSLR. When you've pushed that camera, when you're out every night, you're taking pictures, you're really enjoying yourself, you've got it hooked up to your telescope, you're capturing the moon and the planets and nebulae, all of these things, and like you've reached the limits of what you can do with that setup, then you're hooked. Then it's time to
Yeah.
go and buy a proper astronomical CCD camera, because you're going to use it. And then, yes, you're going to spend anywhere between 500 and $1,000, but that's its only job, and that's what it's really good for.
And one of the things that research has found, and I don't know who does this research, it deeply amuses me. Um, Individuals will spend as much on their hobby as they spend on their car.
Right.
So it doesn't matter what your hobby is, you are cumulatively going to spend as much on that hobby as you would spend on
Yeah.
a car.
Yeah. Whatever the hobby is.
So look at your car and
Yeah.
figure out.
Here on the West Coast, it's bicycles. People can easily spend 10 grand on a mountain bike. No
Yeah.
problem. Let's see. The albino king. What's a good set of binoculars to get?
I like 10 by 70s. I
Mm-hmm.
just like the field of view on a 10 by 70.
Yep.
So many different people
Yeah.
make them.
I've got a 15 by 75, and I like them.
Yeah.
They're a little heavy though.
So the key thing to look for is to make sure that they have a coating on the front lens to prevent light from getting scattered out. If you're going birding or something, there's so much light, you're not worried about scattered light. And so they can go cheaper in making birding binoculars than in making astronomical binoculars. Companies like Orion, Celestron, Nikon, labeled for astronomy, are all completely reasonable.
Yeah. Yeah. So all the manufacturers, Orion makes good ones.
Yeah.
Bushnell, Celestron, the Canon. I mean, if you want like really good binoculars, if money is no object, because normally we recommend binoculars because you want to start, but one of the greatest experiences you can have in astronomy is looking at things with image stabilizing binoculars. So if you've got some money, you're looking at somewhere in the $500 to $1,000 range for a pair of binoculars, which sounds ridiculous, but totally worth it.
So the first time Fraser and I encountered these, they were community member Michael Mayers, and we were all on a cruise to visit Mayan ruins the year the Mayan calendar ended together. And he handed them to us, and we're like, "Oh, we're fine." And they were like, "No, I shall live." It was such an amazing experience.
Yeah. And so you're looking at, I'm trying to see now, I'm looking on, say, $500 for a pair of 10 by 30 image stabilizing binoculars from Canon. And those are amazing. They make an 18 by 50 version, which costs $1,400.
Yeah.
But you will never be willing to look through a pair of non-stabilizing binoculars, because when you think about, say,
all your hand shaking goes away.
Yeah, all of it. You just you point these up at the sky, you look at some object, you press the button, and then just space stops jiggling. And now you can see everything in the field of view. They are the greatest.
And we invoked Michael. I mentioned his name, and he showed up in the Twitch chat.
Oh, great.
Hello, Michael.
Yeah, thanks, Michael, for spoiling us forever on what the night sky could look like. Yeah, it's funny. I do really like those binoculars.
Yeah.
So that's what I would. So if you want heavy binoculars, go for the like 15 by 75, but they will make your arms tired. So you want to find a way to sit outside where you can prop up your arms, your elbows, so that you can, and then you just look everywhere. You just fall into the sky.
I kind of love combining them with my hammock.
Yeah, hammock is great. And there's a guy out of Oregon that's building 3D printed, essentially a double telescope that acts like a pair of binoculars. And I really want to try. We've written a bunch of articles on Universe Today, but I've never actually gotten a chance to use them. But I would love to try that out sometime. Yeah, to be able to see the sky. There's you can even test this out. Look at something on the wall that you can just barely read with both of your eyes. Like walk away from some text on a wall so you can just and then cover one eye up and then cover up the other eye up, and you'll see that you can't read the word anymore.
Yeah.
And that's because there's something that your brain does with binocular vision to make the view even better. And so it's not like you're seeing with both eyes at the same time. There's something extra that you're getting with being able to see both eyes. Let's see. Arjun had a question as well. Oh, no, I'll find it in a second here. Oh, here we go. Yeah, Arjun asks, what software do you use for stacking so that you can get rid of the atmospheric disturbance?
The software constantly
Yeah.
changes. So there you're much better off asking Bill Nash, because I'll only take my own data maybe once a year, and I have to relearn what the latest, coolest tool for
Yeah.
doing that is.
And people
IRAF is my answer, but
people
IRAF
use
should not be your answer.
Sky Stacker Pro. There's a bunch of different software, and it depends on what you're doing. So if you're using, like, if you're trying to catch planetary images,
Yeah.
they'll use, like, you'll take video of the object that you're trying to capture, and then
Yeah.
you'll process the whole video, and it'll look for good frames, and then grab little pieces of the planet and stitch together a total image made of all those pieces. Registack, someone's mentioning.
Yeah, Registack is the one I remember,
And
but I'm
then,
pretty sure it's been supplanted.
yeah, and then there's a lot of software that people like for doing the, like, if you're going to record a whole bunch of separate images of the sky and then stack them up. So you just need to find out what people are using, and every astronomer will give you a different answer.
Yeah.
And try them out. A lot of them are free. A lot of them are freeware or shareware, and you can try them out and find what works best for you. So it's another rabbit hole to go down. John Senfield is saying, for general sky watching, especially meteor shows, a pair of very low powered binoculars are best. Something like 2.3 times magnification or even less. And so we talk about binoculars, say 10 by 50. The 10 is the magnification. The 50 is the size of the 50 millimeters is the size of the lenses.
Yeah.
So a 2.3 magnification, that's a very wide field of view, very low magnification, but you're seeing the sky 2 or 3 times better than you could with your own eyeballs. But then now you can see meteors and all kinds of good stuff. Yeah. Yeah. Just like it all depends on what you want to see. You paused just
Field
as
of
you
view
were.
based on how I wanted to be able to star hop around, and I'm sorry.
Yeah. Your internet is cutting in and out. It's been doing this for a few weeks now. So I don't know if you've noticed this with has this been happening with other things you've been doing?
No, it may just be this time of day.
Okay.
So what I was saying was I chose the field of view size that I wanted based on being able to get globular clusters all the way into the field of view and easily star hop to be able to find things like Andromeda.
Yeah.
So just everyone has a different size that they end up preferring. Go to, after plague times, go to a star party and try out a bunch of people's different binoculars. Failing that during modern times with plague, I just forgot how to pronounce stellarium. Stellarium will allow you to put circles on the artificial sky that shows you what is the field of view of different pairs of binoculars. So you can essentially try out pairs of binoculars in stellarium to figure out what size gets you to what you want to see.
Right. That's really cool. All right. I think we're just about at the end tonight. Now we will. Someone's saying sunspots causing the. No, there's no sunspots. The sun is at its quiet period. But we will. We'll be going into more detail about this. You're almost making us preview next week's episode. You're giving us some things to think about for topics we're going to want to talk about, because that's what next week's episode will all be about. Esther Gainey says, "Can you see Andromeda well with binoculars?" Absolutely. Yep.
Depends on where you are. You have to go somewhere dark, but yes.
Yes. Yeah. I mean, it's never going to look like a beautiful swirling spiral in the sky without taking a photograph.
Yeah, that requires a mounted DSLR minus the telescope.
Yeah. So you're using your meat cameras, and they're not very good.
Yeah.
All right, so we've reached the end of our episode. Thank you, everybody, for watching us, both on YouTube and on Twitch. Thanks to all.
One final thing. Dog.
One final thing. Dog.
We are doing a CosmoQuesticon event July 17th through 19th. Tickets are now available. All proceeds go to making sure that our part-time staff have benefits. I would really like to have dental insurance. So please help us provide health benefits, get amazing entertainment. We are going to have, I can already announce that Amy Davis Ross is going to be our artist guest of honor. And the highlight item in the art auction is going to be a telescope donated by Explore Scientific that she will be painting.
Fantastic. All right. As I was saying, thanks everybody. Thanks, Pamela. Thanks to our mods. And we will see all of you next week.
Bye-bye.
One last time.